Namaste viewers. I am Dr. Sunita Goyal, working as an associate professor in the Department of Applied Sciences and Humanities at ABES Engineering College, Ghaziabad. In the subject Engineering Chemistry, today we'll discuss about the topic conducting polymers. Polymers in general are the best conductors of electricity. This is because of the non-availability of pi electrons in their polymeric backbone. Therefore, they find applications as electrical insulators. But now, in recent years, the polymers have been synthesized which are having the conductivity which is comparable to the metals like doped polyacetylene. This polymer is having conductivity that is 1.5 into 10 to the power 5 Simon centimeter inverse. However, the conductivity of copper metal is 6 into 10 to the power 5 Simon centimeter inverse. So such type of polymers are having conductivity because of the change in their structure. Therefore, the polymers which can conduct electricity are known as conducting polymers. Polymers can be classified into two parts, intrinsic conducting polymers and extrinsic conducting polymers. The intrinsic conducting polymers are, by virtue of their structure, are the conducting. They can be divided into two parts, conjugated conducting polymers and doped conducting polymers. While the extrinsic conducting polymers can also be subdivided into two parts, two ways, like the polymers with conducting elements and blended conducting polymers. So first we'll take the intrinsic conducting polymers. The polymers which are conducting but because of their structure, change in structure, as they have extensive conjugation of pi bond and sigma bond or the double and the single bond. They are known as intrinsic conducting polymers. There is no any externally added atom or impurity is there, but they are conducting because they have conjugation in their polymeric backbone or the main chain. They can be conducting by two ways, either by the conjugation in their polymeric backbone or by doping their structures. So, when we are talking about the conjugated conducting polymers, they have the conjugation in their polymeric backbone of the pi bond and the sigma bonds that results in the formation of valence band and conduction band. This is the way we are having this conduction. Here, the availability of pi bonds are there. Therefore, the availability of pi electrons will be there, which are freely moving electrons and easily available for conduction. Therefore, the band gap between the valence band and the conduction band in such case gets reduced to a certain extent. This band gap gets reduced. Easily electrons from valence band to get conduction band freely. Such type of polymers are polypyrrole, polythiophene, polyacetylene, polyparaphenylene, etc. For example, N molecules of acetylene, when they polymerize, they get converted into, after the polymerization, they get converted into trans-polyacetylene this way. This is the conjugation system. Similarly, we can have a ring structure like polypyrrole, polythiophene, etc. This is the pyrrole when it gets electropolymerization. On electropolymerization, hydrogen molecule eliminates from its structure and it gets converted into this conjugated system. We are writing here only one ring but in a staggered way or in the opposite way, the rings will be combined. So the conjugation double, single will be there and it is the extensive conjugation. This way, the band gap between the two get reduced from 0.5 to 1 electron volt approximately. However, the band gap for metals is 0 and the band gap for insulators is high, that is, insulating polymers is high, that is 1.5 to 4 electron volt. So this is the intermediate band gap, therefore they are showing conductivity. But for any practical applications, the conductivity in the conjugated systems is very low. Therefore, we have to enhance this conductivity by doping. So doping is the phenomena in which we introduce the positive holes or the negative charge in the polymeric backbone. This can be done by using electron donors or electron acceptors. They help to make them conducting. And by doing so, the large gaps between the valence and the conduction band is bridged by by the formation of some new energy levels or new energy bands between these bands, valence and the conduction. So the electrons which cannot move from valence to conduction band directly because of the large band gap, they can move from valence band to these new energy levels, which can have some positive holes or the valencies or the vacancies here. Similarly, the electrons which cannot move from valence to conduction band directly, they can move from here, which are having negative charge or the negative electrons here in the extra energy bands to the conduction band. Anyhow, we are discussing here about the reduction of this band gap by formation of new energy levels between the valence and conduction band through the doping phenomena. This doping can be done by two ways, N doping and P doping. As the name suggests, the P means the positive hole. The formation of positive holes will be there in the P doping. This can be done by the removal of electron from the polymeric backbone by using Lewis acids. Lewis acids like halogens, iodine, bromine, etc., or FeCl3, ASF5, etc., type of Lewis acids. Lewis acids are basically the electron donors. Through the chemical reaction, the polymeric backbone and Lewis acid, we can oxidize the polymeric backbone. Therefore, polymeric backbone will be having a positive charge. This polyacetylene, for example, we are taking it as having an extensive conjugation of pi and sigma bonds. So this extensive conjugation will have this Lewis acid, a chemical reaction with this Lewis acid, and will have a positive hole on this polymeric backbone. Therefore, because of the presence of this positive hole, there will be the enhancement of conductivity of this polyacetylene or the conducting polymer. And another way we can do this doping, that is the N doping. By N doping, a negative charge on the polymeric backbone will be created. So negative charge can be done by using a Lewis base. Lewis bases are actually the electron donors. They can have negative charge or the lone pair of electrons or the electrons which can be donated. So the alkali metals like sodium, lithium, or alkaline metals, alkaline earth metals, or the organic bases like naphthylamine can be used as electron donors, or the Lewis bases, which can donate electrons to this polymer, which is having an extensive conjugation, and its example we have taken here, polyacetylene. A negative charge will be created over this conducting polymer. So we can get N-doped conducting polymer through the process of reduction of this polymer. We can do this doping by the characteristic or the property of these polymers, that they have a low ionization energy or low ionization potential. And also they can be N-doped because they can have a very high electron density. Therefore, either they can a very high electron enthalpy. Therefore, either they can easily be oxidized or they can easily be reduced. Now, the second is the extrinsic conducting polymer. These are the polymers which can be made extrinsic by two ways. Some externally added ingredients will be there for making the extrinsic conducting polymer. So they can be polymers with conducting element and polymers with conducting blend or blended conducting polymers. So polymers which are having conducting elements like carbon black or metal oxides, these are the conducting elements which are added to the conventional polymers. These polymers act as a binder and they hold these conducting elements and make a solid entity. Therefore, such type of polymer is known as extrinsic conducting polymer. Another type of extrinsic conducting polymers are the blended conducting polymers. In the blended conducting polymers, the conventional polymer is blended with a conducting polymer. Here, the conventional polymer gains the conducting property. Here, the polymers are having, they are light in weight and they have high electron densities. They have high energy densities. They are very cheap also. They get their higher mechanical strength, their chemical processability is also very high. Physical strength is also high. Now the applications of conducting polymers, there are vast number of applications of conducting polymers in which we are taking only a few here. One is in the formation of rechargeable batteries. So doped conducting polymers, they can be used as charge storage materials because of their small size, long lasting, and they can have very high electron density. Their utility is very high. They have very high current density also and have high charge to weight ratio. They are very light in weight. They are also working as an anti-static material. For example, doped polyaniline, it can be used as an anti-static material which avoids static electricity in the plastic carpets, in the offices or other areas. Similarly, they can work as optical filters. As we know that radiations from the computer screen or other electrical devices are very harmful to human eye, they can be absorbed. These radiations can be absorbed by the conducting polymers coating and on these casings. The conducting polymers can work as a very good analytical sensors. They can sense the chemicals and different properties like pH. They can sense to pH, oxygen levels, nitrogen, sulfur oxides, ammonia, glucose, and many other chemicals. Even at very low concentrations, they can detect or sense these chemicals or the substances or the properties. That's all about this lecture. Many more applications are also there. Thank you.